Good day, class. You're welcome to this class, SVG 201. We are touching the topic today. The topic we are studying today is chain surveying. Chain surveying. From the word chain, the topic was coined from the word chain. When we say chain surveying, it's trying to tell us the method of surveying that involves the use of chain. In the olden days, they were making use of chain. But despite the fact that things are changing, they're no longer using chain, but they want to retain the name chain so that we don't lose sight of history. Chain surveying is the method of surveying in which only linear measurements are made in the field. Linear measurements in the field. And that was what was common in the olden days. And today you can still carry out measurements linear, only linear measurement, and with that you can fix position. Remember when we were touching various means of describing positions. Remember we can carry out purely linear, and we can carry out a mixture of the two. Remember, we want to fix a point. We want to fix another point. This point is known. This point is known, but we don't know this one. We can carry out measurement from here to here, measure out for this one. And if you want to plot, if you know the scale, you can make an arc there. Here, you can make an arc there. The intersection will help you to fix this point, see. It's purely linear. This is the baseline which we have determined by chaining 2 or more times. So with that, we can determine this position. And there also I mentioned that you can fix this position by intersection. That is when you can take angle from here, theta 1, theta 2, and you can fix this point. Once you have known this distance, you can apply a sine or cosine rule to determine this position. That's one. But now we are focusing mainly on this. Sometimes it can be purely angular, it can be a mixture, distance and measure and angle. For example, look at this offset. This distance to point C and angle. And this is the baseline, AB. So we are focusing on chain surveying. It's a method to adopted to survey an area with simple details. What do we mean by details? Details represent both artificial and natural features you find in the field. When we say details, this can include the road, palm tree, water bodies, electric pole, building, any feature that is artificial or natural are categorized as details. So in the area where you don't have too many details, chain survey method will be suitable. And that can also be done to extend to large countries. Like Great Britain was surveyed using this method. That was a serious work because they have to get to the hills and extend baselines where you can see from one or the other. And you know definitely they're not going to be measuring with chain. I'll show you chain and you know how cumbersome it is. But the chain name is retained so that we not lose sight of history. So if you are fixing positions, you can fix them by triangulation, traversing, another means. Trilateration. Trilateration is a method whereby you only measure the lateral. Trilateration. Trilateration. And that is also very close to this chain surveying method, where you carry out only purely distance measurement. In this situation, you don't need rigorous calculation, rigorous adjustment. You can fix your positions by just through graphical means, plot and build up your chain, the whole figure. So use this method also in plotting the details. We'll show you more of this as we go on. Look at this diagram or this picture. This is how the chain looks like. You can see the handle called the groove, the bronze handle. Then you have chain link. You can see the link. All of this were made with metals, and you can see the links. How they are joined together, and that's how they are stretched on ground. Look at this link to this link, 20 centimeters. This one to this one, one link is about 20 centimeters. All of this one, before you measure, all of this, why is this then? Just to make sure that you have equal measurement, fair measurement, that one did not cheat the other. You know, before they will use pacing, you can pace. So look at another one. When you look at the chains, the brass ring, you have all of this attached. You have tallies. You know, this one has one tooth, this one has 2 teeth, this has 3 teeth, this has 4 teeth. And they use these ones to demarcate for anybody who is carrying the chain to know. Instead of start counting from the link 1, 2, 3, which you can mix up. By mere sighting the tallies, you will know exactly where you are. Each tally is placed at every 2 meters. As this case now, look at it. From here to here, 2 meters, 1 tooth. Another 2 meters, 2 teeth. Another, you can see 3 teeth, 4 teeth. So it means here you have 10 meters. Where you have this another type of tally, this one. This one signifies 10 meters. So if you see this type of thing, you can know that, oh, we have reached 20 meters and all that. So that's how the chain was designed, constructed. But one thing you have to notice is that it's very, very heavy. It's very heavy. And it is a metal, such that if you drag it in the mud, it will rust. And you have to clean, you have to wash, you have to put a grease to ensure that it can last. That was the people of old, they passed through, those who started surveying. But while we retain the names, the equipment used nowadays have changed. But one thing you must note is that the measurements taken are purely horizontal, or on length or distances. Angles are not included. Where part you are going to include angle is going to be minimal, like you can judge with eyes. Oh, this 90 degrees. If I stretch my hands like this, I means this way. If you look at it now, and I make a line like this, it means the angle between my arm and this line is 90. Look at me as I stretch my hands. The whole of this is 180 degrees because it's an angle in a straight line. So we have various ways of determining rough estimate of angle. So that is that. Now let's look at the equipment. We said that it is chain. It was chain they were using in the old days. But today, the world today is moving at a very alarming speed, and no one can afford to be dragging and you want to measure. Even these days now, you have a distometer that you can, just like your handset, when that has laser like this, and you want to measure any distance from one place to the other, just point the laser to where you are. From where you are, it will display it on the distometer for you to know the distance you have measured. So we are nobody is bothering to carry chain these days again. So it is cumbersome then, but now we have other things of determining distances. So, but when you are carrying out chain surveying, There are other ancillary equipment you need to carry along: arrows, ranging poles, leaning tape, offset stand, and a field book. An arrow looks like this. That you can pin to the ground as you measure, just to know how many times you have dragged your tape on ground. Assuming you want to measure 500 meters now, and you have 100-meter tape. If you take if you stretch the whole tape on ground, and you move to another one again, by putting arrows there, and somebody at the back coming, picking the number of arrows, can tell you how many times you have measured 100 meters. But if you don't have that arrow, somebody can say, oh, I measured that line 4 times. Somebody say, no, it was 5 times you measured. Or somebody can even say it was 3 times, because you are not consistent. But the arrow can just tell you to dispel that kind of doubt. So look at the equipment now. For linear measurement, we can measure that with chain, tape, or steel band. Nowadays, what is common is is tape. We have linear tape, we have steel band, 100 meters length, 30 meters length. These are the ones that are common now. So then another way you can measure, you can also carry out linear measurement through a means called tachyometer or tachymetric means. Tachymetric means is a situation whereby you combine optical equipment with your leveling staff. So, or something at the other hand. For example, you can, if you have a level instrument is an instrument. A level instrument is an instrument used for carrying out for determining height, while a theodolite is used to determine angle, to measure angle. Both equipments, level and theodolite, they are optical equipment. The optical equipment, because they contain lenses, there are arrangement of lenses in the equipment. So, but when you now bring this level or theodolite, you use it along with another something, another equipment at the other hand. Assuming you have here, and you stay there on that equipment, and you want to measure distance from here to here. You want to measure from distance from A to B. Instead of stretching tape along the line, on the floor, you can place something here, which this theodolite or level can read. What we normally make use of is a leveling staff, for example. A leveling staff. When you place leveling staff here, and this one size it, we can take some readings there. That readings, we can now use it. We can now mathematically determine the distance from here to here. You are going to learn more of that later. And sometimes also, if you can use leveling staff on this other hand, or a substance bar. A substance bar. For example, if you have a theodolite there, you want to determine this distance, there's a bar here, which is normally horizontal. You place this bar on something, on a pivot, and it is horizontal. This bar is a substance bar. Substance bar. You place it on a tripod that it can stay horizontally on that tripod, and this is of a fixed length. It can be 2 meters. Fixed length, 2 meters. So, if you make this thing close by, if you move this bar closer, or you go wider, the angle here will change. So the farther it is, the wider angle you have. And the wider the angle, the longer the distance. If you bring closer, the shorter the angle, the shorter the distance. So that's a substance bar, but this is leveling staff. So when you use substance bar and leveling staff, or leveling staff, together with your theodolite, to determine your distance, that method is what we call the tachyometric method. The tachyometric method. We also have another equipment that was designed as a tachymeter. We call it a tachyometer. A tachyometer. It's a theodolite, but it was designed purposely to do the measurement of distance. So apart from the direct measurement using tape or chain, you can use a tachyometer. Another one is electromagnetic distance measurement, EDM, not your EDM here. This is EDM, electromagnetic distance measurement. This is attached to your theodolite, and that one has a reflector at the other hand where your assistant is, or we call it slave, and we have here at the other hand here is the master. So you communicate, you send signal. It has electromagnetic distance measurement, electromagnetic equipment attached to your theodolite. And once you press the button, it sends signals to the remote here, and the time it takes to go back and to and fro will help you to determine the distance. That's an electronic method. So these are three measurements, three ways of carrying out purely linear measurements. Now look at the principles of chain surveying. The principle of chain surveying is that if you can determine, if you can measure any three sides, and you can plot them, that we can determine, we can fix position. So if three sides are recorded, then we can fix position. For example, this is a point, this is a line. You want to fix this position. This one is known, call it A, B. If it is possible for us to measure this on ground, and it's also possible for us to measure this on ground, this position can be fixed. We told you earlier that minimum of 2 measurements are required. So if you measure from here to here, you can make an arc there. You cannot fix this position with only one measurement. You need to confirm it from one hand. So if you measure from here to here, saying again, you have an arc there. The intersection of the points, what you have here and what you have here, will help you to fix this point. So this is what you see. So if you now have a parcel of land, let's assume this is a parcel of land. You want to map, you want to determine. If it is possible for you to measure, look for the longest line. If it's possible for you to measure the longest line there, which we call the baseline. This baseline. And no matter what you normally do is that we normally write it, we put double line. That means we double chain. That is, we measure it twice, just as a matter of check to ensure that it is very, very accurate. Once that is done, your baseline, you cannot begin to build series of triangles on this baseline. For example, I can take the diameter into this one. I can measure here as well. If I can measure this one line to this point, I can measure this one to this line, this point, then with what I explained earlier, we can fix this position. And from here, since that you have fixed this position, then we can fix other position here. You can still go on this one as well. You can make another triangle there. If you can measure from here to here, make arc, from here to here, make arc, we are able to fix this position. And you can as well maybe check here. This is a triangle, this is another triangle. You can fix this position. And you can measure as well. Once you know this one, you can measure to this point or to any point. So what we end up doing is that we now fix everything divide the whole land into a series of triangles. Once you can know the three triangles, and they can be plotted. And once you can plot them, the whole place can be covered with that method. And this is the method that was employed in the survey of Great Britain long time ago. So that's the principle. So it means you can draw directly as you measure. So what is important in this situation is that you have to arrange it. Your work must be arranged, because it also has its own constraint. This method has its own constraint. Assuming you have divided into series of triangles, and you go and encounter possibly there is a building here. This measurement will not be possible. So, and when you have too many details, it will not allow you to really design your triangles. So, that's one of the limitations this has. So, it is always advisable to get your diagonal or the longest distance first, then build or your structure. You can build the diagram on it, and you execute on the field. So methods of detailing. We want to look at some methods of detailing. That is, assuming there are, I told you details earlier, assuming there are features in the land, which normally you have. You can have river, you can have stream, or you can have river, you can have building, you can have palm tree, you can have roads, you can have roads like that. All of these ones can be picked. Those are what I call detailing. There are various methods of fixing the positions of those features or those details of capturing them and fixing them in your plan. So one of the methods is offset. Offset, when we say offset is just a measurement taken from a baseline at perpendicular, a measurement taken at perpendicular to a baseline. Let me give you an example now. This is a baseline, call it A, B. This position is for a point you want to fix, call it C. You don't know this position, you want to represent it. So from this baseline, which you know, take a measurement that goes perpendicular. One thing that is common, one thing we know about offset is that offset must be taken perpendicular from a reference line. This seems like it's like our reference line now. So if you take a perpendicular distance from that point to your baseline, then that method is what called offset. And the issue is that in this case now, the offset, the perpendicular distance, you can determine them, the right angle, by judging with eyes. Look, for example, if I stretch my hand like this, I know that anything goes this way will be perpendicular. And when you come to the field as well, you can also judge with your height. That's one of the ways of achieving perpendicularity. Then by swinging offset tape to obtain the shortest measurement. You know, if you can take, you will swing from a particular line. The shorter distance, if it is going like this, assuming this is a line you are working on. If you can check, if you measure, this will give you a distance, maybe 15.5, and this one maybe gives you 15.7, and eventually maybe this one gives you 15.2. The shorter distance you have from this point to any of your swing length is going to be the perpendicular something. So we cannot fix this one as a perpendicular line to this because it goes the shortest. So by swinging the offset tape to obtain the shortest measurement, then by setting out the right angle with optical square, that's another equipment we normally use, like our handset. It looks like handset. We call it optical square. We have another one called a cross staff. You can check from you can Google for them and look for how they look like. Builder square, all of these can be used to determine perpendicular. Then you can also use isosceles triangles construction. you know, two lines, you know, are okay, you know, are equal, and if this one is equal to this, then you will know that from here to here, you can divide into two to help you to know that this is a rectangle. So isosceles triangle, we can determine that. You can determine which is whether it is perpendicular or not. Then another one is ratio 3, 4, 5, like in your Pythagoras theorem. You can choose 3, 4, 5, or 4, 3, or I don't know, anyone. 3, 4, 5. This the hypotenuse is there. So with this, we can determine our rectangle. So these are ways of achieving a perpendicularity to a line. So look at this now. This is a chain line. This offset. This is a line from this reference line, and we take it perpendicular to this. Look at this now. Another method of fixing your detail is what we call press measurement. Now, this is a detail. For example, let me take another diagram. This is a building. This is your reference line. Let's call this one A, B. The measurement starts from 0 and on like that, maybe 10 meters, 20, 30, 40, 50, and on like that. And you want to fix this position. We need to know where it is perpendicular to this line. At a particular point here, I can assume that we can achieve perpendicularity from here. So this is perpendicular to this. So we want to fix this point. So this should be around 20, 30, this will be around 22. At 20 means that when you have your field book, you say at 22 meters, I encountered a building, the beginning of a building. And you will fix it at 22. At 22, there's a building. And this is how you normally fix it in our field book. The field book looks like this. It has center. At the center, maybe let's call this one A. And the other hand there, B. This is the center of the book. This is your book. This is your book. It has margins. It has those margins. It has those margins on your book. At the center, you draw double lines at the center. At A, O is 0. At the end of this line, from this one signifies your line. This is on your page book or your field book now. At B, let's call this one 52. That's the total length of that line. As you go, you say, okay, at 22 meters, I saw a building. This is a building, the beginning of the building. Where was it? Towards my left, because you are moving from this direction. So it's on the left, so you place it here. You draw that building like that. How the building looks like. Just like, look at how I drew that one now. So at 22, I encountered the building. How far is it from the chain line, from the reference line to that end? Oh, it's 4 meters. Okay, I can now say this is 4 meters from here to here. So I fix this point. As I go on, when I reach this place again at, let's say, at 44, I will say at 44, I saw the end of the building. The end of the building at 44 is this. So what is the distance from here to here? Oh, it's 4.5. I say, okay, 4.5 from here to here is 4.5. It means that from here to here is 4.5. So you note it in your field book like that. And when you fix your details like this, and you have noted them in your field book, we call it offset method. Now, the plus measurement is not far from that. The only thing about plus measurement is that these are additional additional measurements, plus, that is, plus additional measurement to the offset. These are additional measurements taken alongside, in addition to the offset which you took. So if I want to take this one now, if I want to have taken to this point to help me to know the beginning and the end there. But I want to record this one also to show the shape of the building. Oh, this one is 5 meters. I can now say plus 5 meters. If I go this one, maybe 3 meters, I can now say plus 3 meters, plus 2 meters, plus 8 meters, until I finish this building. That will help us to be able to plot the building later when we get to your office. So that's what we mean by plus measurement. They are the additional measurements taken in addition to offset, usually around building. So that's what that one is all about. Then another method of taking offset, or of determining details rather, is taking of ties. Ties, what do we mean by ties? Ties are measurements. Okay, let me not finish this one. Now, instead of taking perpendicular distance from your chain line to the point, you can decide to take, pick your measurement from any point on your reference line. For example, I can take measurement from here. At this point, I can measure to this point, and at another point here, I can take another measurement to this point. So this, if I measure like this is what we call tie lines. You will notice that at 12, this is 10, at 12, maybe around 12, I take measurement 12. And I take this measurement to this place, maybe 15 meters. At 28, another one to the same point. So when you take such measurements that is not perpendicular from the line to your detail, such measurements are called ties. They are called ties. Before you can call them ties, it must be a minimum of 2. It can be 2 or more. So a tie line or tie lines are distance taken from 2 or more selected points on the chain line. This is the chain line to point of details. This is a point of details. This is another point of details. So you can take measurements. You can take it from here as well, but it may not necessarily be perpendicular now. But from this one, another one 2, another one 3 to this point. So we normally do that, especially when you want to fix positions that are very, very important to us. They are crucial points to us. For example, your station, your control station. You may have pillar there. You may have something there that you want to use to control your work. In such case, the point is very, very important to you. So somebody can come tomorrow and remove your pillar. But if you have taken ties from that point to some trees, to some important features, if they remove that pillar, you can fix them back based on the tie measurement. So you can take note of that. And look at this. I've explained this is a tie line. This is a tie line. This is the point of detail. Now this one looks like a check line. The dotted one is check line, and this is the chain line or the reference line. Check or proof lines. So that I've shown to you to help you to detect error. So you read more about this, about check lines. Now let's look at some of the errors we encounter in chain surveying. We have 3 categories of errors. We have systematic, compensating, gross or mistake. Again, we have 3 categories of errors in chain surveying. One is systematic. Why do we say systematic? If it is positive, it will continue to be positive. If it is negative, it will continue to be negative. It cannot be mixed together. So that's why we call it systematic and cumulative. For example, if you take a tape of 5 meters and the manufacturer told you this tape is 6 meters though, but in real sense, it is 5 meters. It means that anytime you measure with it, if you have not checked it against a base, if you have not confirmed that distance to be 5 meters, and you just go blindly based on your manufacturer's prescription, that this 6 meter tape I've given to you, and you went ahead to measure like that, you will be incurring some errors. The manufacturer told you the tape is 6 meters, but in reality, when you check it against base, it's 5 meters. If you go ahead to measure this line, for example, it's a line to measure, maybe about 20 meters length, I don't know, about 20 meters, but you assume that it is 6 meters. You measure the first one to this place, you call it 6 meters. Another one, you call it 6 meters. Another one, you call it 6 meters. And you now measure this one, maybe 2 meters thereabout. That one, maybe 2 meters. At the end of the day, you have 20 meters. But in real sense, the tape is 5 meters. If it is 5 meters, 5, 5, 5, let's call this on 2. It means, in real sense, you have only measured 17 meters, not 20 meters. So, such error is cumulative. But when you now detect later that the tape you have used was a 5 meter tape instead of 6 meters, you can now say, instead of going back to the field, you just know how many times did I measure. Oh, 3 times I measured the full length, 3 meters. So therefore, I can deduct 1 meter from each of them. So to tell me 3 times. So 3 meters. Instead of going back to the field, I can just remove that 3 meters from the overall something that I have and to give me the actual. So such is, we call it cumulative or constant. If once it's 1 meter, it will continue to be 1 meter. If it is 0.5 meter, it will continue to be 0.5 meters. That's why I call it constant error. These are some of the, and how do they affect the accuracy of the work? They say they are proportional to the length of the line. The errors are either positive or negative. Now look at another group of error, compensating. This one can swing either way. It can be positive, it can be negative. So you have compensating or accidental or random error. In this case, there's no matter how good you may be at measuring distance or carrying out measurement, no matter how careful you are, you will always incur this type of random error. And that is what we normally adjust in do rigorous adjustment to remove in surveying. You always find them, but because it is normally distributed, randomly distributed, so it obeys the law of normal distribution. Because no bias there, nobody knew anything. So this is a normal distribution curve, which we will find out in the statistics. So because of that, we have to subject it to statistical approach, to statistical method in order to solve that problem. And that's what we will do at higher level of surveying, trying to carry out adjustment. What we adjust, we can only adjust random errors, not systematic error. If you are going to adjust systematic error, there are other approaches, but it's not the major thing we do in surveying to adjust systematic. But mainly we focus on random error. So these ones will either be positive and negative. So you cannot do without them. Now the third group of error is what we call gross or mistake. This is not acceptable at all. If you don't know it, you don't know it. For example, somebody measures a line instead of and sees on the something 10, maybe 10 on the tape, and instead of, and he has only measured one, it's 10 millimeters, but he says it's 10 centimeters. So it's a big difference. Or it says 100 centimeters and maybe call it 200 cm or 100 millimeters. They are not the same. So in such case, that person has to go back to go and learn how to measure. If you have something, maybe this one's 1 and you call it 10. 1 meter to 10 meters is quite enormous. That's about 9 meters. So that person will find that himself somewhere. So it's a big mistake which must be avoided. Mostly this leads to carelessness or ignorance. Maybe somebody does not even know that how to measure. So that would be a serious problem. For example, it can be, we know see more, someone can misplace figures. If maybe after measuring a line, instead of writing 3.5, the person wrote 3.5, 5.3. There are 3, 5 and there, but the difference between two of them is 1.8, which is big enough, So that this kind of error cannot be adjusted. They have to go back to the field and measure again to show that you have done. So let's look at cause of this mistake. So these are some of the mistakes in chain surveying that we need to avoid. I've told you erroneous length of chain. If they tell you the tape is 100 meters, check it against a base, a standard base, which has been tested and proved to be known that it is true. So with that, will help you to know exactly if the tape you are using is right or is the correct value or not. So we have what we call nominal length. We have the actual length. So you subtract the nominal length. If they tell you it is 100 meters and the base tells you it is 100.05, the actual length is 100.05, but the nominal length quoted by the manufacturer is what we call the nominal length. So you subtract the nominal length from the actual length and you multiply by the number of chains you have, chain measurements you have carried out. That will help you to avoid, to know that error and remove it. So that one can be positive or negative. So you read more about that. Then bad ranging. If you don't align your poles very well, then it can cause problem. For example, look at it. I'm to fix a point between 2 points. I'm to fix this is a line. This is a straight line. AB. Ranging is method of fixing points in between two endpoints, fixing poles along the two endpoints. So in this case now, normally when we do that is when distance is too long, that your tape cannot be stretched at once. So if you don't, so therefore you need to fix points in between these two endpoints on a straight line so that you cannot measure from here to here, that your tape can reach and here, and with that you can have a perfect line measured. But with situation where person who is ranging, who is to align points between here and here, does not do it very well. Possibly the person put the pole somewhere there, you know, thinking that it's a straight line. You know, this is a bad ranging. Actually, later you now come here. So if somebody is now coming to measure, the person will measure from here to here, from here to here, from here to here, and come here. That's not straight line. So due to bad ranging, such will be error can occur in our measurement. So read more about that. Another one is bad straightening, whereby your tape is not straight, it wobbles like that of snake. Horizontal, irregular horizontal curve is similar to that. So bad straightening is cumulative. It will be more than what it should be ordinarily. And that one on horizontality of chain. This is normally when you are measuring a place, maybe you have slope, and normally in surveying, when we measure between any 2 points, we normally measure, we convert whatever we have measured to horizontal length. Assuming the point is A, and that point here is B. Look at the terrain. This is slope distance. But what we expected of us is that we should measure from A to B. A to B should be like this. Because in survey we normally measure horizontal distance. So if you measure horizontal, if you have measured from here to here slope, you need to convert it to horizontal equivalent of that. So if your tape is not horizontal and you have measured like that and you could record it like that, then be sure that you have not carried out proper measurement. And this videos of you people in architecture or building and all that. Please take note of this. Whenever that you are measuring, we are measuring on horizontal plane. Even when the other plane is up, the other one is down, and you have to ensure that you convert what you have measured to truly horizontal length. And then look at this particular one method of doing that. You can carry out step chaining. That. Instead of measuring like that, you can start to measure like this, maybe from a particular point here, and you measure from here again. This horizontal, let's call it S1, X2. From this point again, measure X3. You can see now these are horizontal, horizontal, horizontal. And on like that, you can measure like that, X4. You can measure like that, to this point, X5, until you get up. So later you can now sum them, X1. This method we call step chaining. So step chaining. You see now, we can now sum, you measure them in bits according to the step as you are climbing up. And you sum them up to give you the total distance from point A to point B. Then we have sag. This is the one you have, those people who sag. This sag, you want to measure from one point to the other, your tape sags, instead of being truly horizontal. Normally this distance will be more than what it should be in reality because of this sag introduced to your measurement. So you need to correct for sag. There's formula for correcting for sag. You can look for that also in your textbooks and check for them. Then we have variation in temperature. This is normal, this is minimal because of the some of the equipment they normally use now, or tapes, they have low expansion, coefficient of expansion. So that is taken care of. So we will not necessarily affect your work significantly. Then careless holding and marking, possibly somebody is holding the tape at 0, somebody is not holding it very well, or if you measure from a point, assuming we have to measure this line, I hold 0 here, and somebody measure up to this point, we'll call it 20. And when you come to, you put arrow here, that arrow there, this person moves to this place, and instead of putting it exactly here, the person puts it here. But the person, on the other hand, has taken the tape to this point, and the measures another 20 meters. What happened to this place? Because the person who came from here did not look at this point very well. He did not know exactly where this person left. So if he continued to do that, that error will continue to accumulate, and that will be a problem at the end of the day. So what is advisable, when you mark a point here, let it be very conspicuous, such that when the person who is here comes there, you will see it exactly. So what we normally do is that on the ground, is either you put arrow there for that person to see, or you put mark across like that, on the ground, so that they will see it to be conspicuous when that person comes, or you can use X. So the intersection will be at that point where you are. So all of these things have to be very careful. You have to be very careful when you carry out measurement. Then we have variation of pull. We can exert different energy, power on our tape. Somebody can draw it so tight, somebody can draw it carelessly loose. So this variation is compensating or it can be too much or it can be too less. So, but with time, this can cancel out about the variation of pull. So it is advisable that when you are pulling with tape, you can use spring force, a spring balance to hold it, to know so that you can exert equal amount of pull on the tape. Then these are groups of gross errors. Displacement of arrow is another. These ones fall under gross error or mistake. Displacement of arrows. If arrow is here and somebody mistakenly move it and you don't know exactly where it was moved, and you go and place it here, then this one will be a problem. Or somebody removed the arrow here and you go and put it here. You know, instead of saying, oh, there's a problem, oh, but he doesn't want people to know, just go and put the arrow there again, and you go ahead to measure. So that would be a problem. Or you misplace your station marks, that would be a problem because you're measuring something different from what you initially designed to measure. And that one is miscounting tape length. I've mentioned it earlier. Miscounting tape length, if you are measuring full length, and if it is 3 times you have measured, and you said it is 2 times, it means that 50 meters is gone if you are using 50 meter tape. So instead of saying that, oh, I measured 150 meters, you will say I measured 100 meters because the tape length, you have missed it up. So you need to go back and measure again. All these ones are gross errors, 9 to 12. Then misreading the tape. If you are to read 2.5 and you go and read 20.5 or 20 point something, you say it's 2.0 something. It will be a problem because you don't know how to read tape. The last one is wrong booking. If you are maybe the person who observed or who measured said that 3.504 and you want to go and measure or you want to go and book, you now write 5.304. But 1.8 meters is gone already because you mix up the figure. If somebody tells you 2.002 and you went ahead and tried 2.200, this is a big difference. So these are the errors that you are likely to encounter in chain surveying. Thank you very much. Have a nice day.